In the last video, we introduced Huygens principle. In this video, we'll use the Huygens principle to prove a theoretical background of law of reflection. Huygens uses principle to deduce law of reflection. Assume that a plane light wave is incident at an angle alpha on the surface A1, A4. So this is the surface, and these are the two medium 1 and 2. So we have this medium 1 and medium 2, and this wavefront or rays of light 1, 2, 3, 4 are getting incident here. So ray number 1 is coming and meeting at A1 first, whereas the ray number 4 has still not met far away at B1, and this is medium 1 and this is medium 2. Let's assume that the light travels in this medium 1 at velocity v1 and in the medium 2 at velocity v2. Now, when the ray number 1 meets here, it forms a secondary source of another spherical wave. So it starts emitting wave like this, and the wave front moves in this direction. Now assume after time delta t1, it reaches somewhere here. In the same time, this rays from B1 reaches the interface at A4. As you can see, as the ray from B1 to A4 travel at a velocity v1, so delta t1 is going to be B1 A4 divided by v1. So with this velocity travel this much distance, hence the time is t1. In the same time, the ray from A1 travel to C1, but at a velocity v2 in this medium. So we can write it like this. Now assume this ray number 2 reaches here at A2, and after delta t2 time, in the same time the ray travel from B2 to A4. So B2 A4 at velocity v1. As it reaches A2, it also formulates secondary source, and finally in T2 it is here. So the rays travel from A2 to C2 with a velocity v2. Similarly, for delta 3, it will be B3 A4 divided by B1 is equal to A3 C3 divided by V2. Now change the color. Now let's observe this triangle. This is our angle of incidence. So this is 90 minus alpha as the perpendicular. This is also going to be an alpha. So we can write sine of alpha, sine of this angle alpha will be equal to B1 A4. This is B1 A4 divided by A1 A4. Now let's observe the other triangle here. This is angle of refraction beta. This is 90. So this is also going to be beta. And now we can write sine of beta is equal to A1 C1 divided by A1 A4. So this is common. So we can simply write sine of alpha by sine of beta is equal to B1 A4 divided by A1 C1. Now this B1A4 is equal to delta T1 into V1, and this A1C1 is also delta T1 into V2. This cancels out, so we can write sine of alpha by sine of beta is equal to V1 by V2. Now, as you have may notice that this expression looks very similar to the Snell's law we derived or arrived at by experiment in the last video. So sine of alpha by sine of beta is equal to B1 by B2, and in the last video we have shown that this is a constant. So probably now we have arrived at what the constant is. It says the velocity of light in medium 1 versus medium 2. So to understand this better, let's introduce a definition called refractive index. So refractive index is nothing but, simply put, a ratio of, so we define refractive index N of a medium. This is a medium in which the light rays are traveling, and refractive index is nothing but the ratio of C by V1, where C is speed of light vacuum, which is equal to 3 into 10 to the power 8 meter per second, and V1 is the speed of light in that medium. So when we take the ratio of C to V1, we define it as a refractive index of this particular medium. Now, as we observed here, says that sine of alpha by sine of beta is equal to V1 by V2. So in our last case, basically we had two mediums, right? We had medium 1, medium 2. Let's say this has a refractive index of N1 and this has a refractive index of N2. Hence N1 will be is equal to C by V1 and N2 will be equal to C by V2, right? Now V1 will be equal to C by N1 and V2 will be equal to C by N2. Let's plug it here and we'll find that C by N1 divided by C by N2. We do that, basically we'll find that N1 sine alpha will be equal to N2 sine beta, or sine alpha by sine beta will be equal to N2 by N1, which is a constant. So this is the law of refraction, or a Snell's law of refraction, and this is the expression we like. We are going to be using it to define and use in our problem, where N1 is the refractive index of medium 1, N2 is refractive index of medium 2. So medium 1 is from where the light is originating, and medium 2 is where the light is going. This is medium 1, this is medium 2. Draw perpendicular, this is your angle of incidence alpha, and this is your angle of refraction beta. As we said in the beginning, our goal in this whole exercise was to find a relationship between these two things. So we had this, interface, medium 1, medium 2, refractive index N1 is N2, and we wanted to know if the ray of light is coming like this at an angle alpha, what angle beta it will go. And now with help of this expression we can simply write N1 sine alpha is going to be N2 sine beta, hence this beta, and hence now we can always get beta by plugging in N1 alpha and N2 into this expression, and this is called Snell's law of refraction, which says that N1 sine alpha is going to be N2 sine beta. Now as we defined the refractive index, which is N2 or any Ni is equal to C by Vi. As we know, C is always greater than Vi, hence the value of refractive index will be always greater than 1, right? Now let's write down the second law of refraction of what we observed using this principle and prove with Huygens principle. The law of refraction, we can simply write two things. The first thing, that the angle alpha and beta will follow this expression. N1 sine alpha will be equal to N2 sine alpha sine beta, and secondly, the ray which is coming in and the ray which is getting in reflected will be always in the same plane, like we said in our reflection thing, right? So all this ray which is coming in and getting reflected will be always in the same plane, like we have seen in the reflection case. Secondly, as we also mentioned in the reflection case, that this law is reversible, meaning the ray is coming not from this direction but from this direction. These angles will still obey the Snell's law. So this will become angle of incidence and this will become angle of reflection. So from N1 to N2 or N2 to N1, this expression will hold. So this is a very important concept. N1 sine alpha is equal to N2 sine beta, and we are going to see a lot of examples in the next video using this expression and playing with it.